Hello, let's do a video on weight. What is weight? Well, first of all, let's recognize that all bodies have mass, and mass is measured in kilograms. Now, the mass is a result of the atoms that you're made up of. So you would have the same mass whether you're here on Earth, on Mars, out there in the Milky Way. You would have the same mass no matter where you are and what you're doing. And however, weight is a measure of what happens to that mass when gravity acts on it. Now, gravity, we would think 99% of the time we're talking about an acceleration due to gravity of 9.81 meters per second. And that's because we're pretty much thinking about what's happening on Earth. But gravity is everywhere throughout the universe, and masses are everywhere throughout the universe. So when we do a bit more physics, we can also talk about the weight of objects anywhere in the universe, and it will vary. Your weight would vary depending on the gravity that you're experiencing. So if you're up in the International Space Station, for example, you would be weightless because the gravity that's acting on you is very, very small. Now, weight is measured in newtons because it's a force, and that's why we're talking about it in Newton's force section. And it's given the formula Fw equals mg. This is sometimes written as Wt. So the force weight is the mass times gravity, and gravity is the acceleration due to gravity, and on Earth that would be 9.81 meters per second minus 2. On your formula sheet you have F net, and you can see that F weight is just a variation of F equals ma. And really, most people wouldn't worry about putting that formula on the formula sheet, but it's there anyway, because we recognise that the acceleration can be a variety of things, including gravity. So weight is different from mass. The weight of an object is the force of gravity acting on the object, so you have a weight force. And it will vary depending on which planet it is measured on, and your weight force. You can also have something which is called an apparent weight, and that's the weight that you feel that varies depending on the accelerations that you experience. So if you're on a ride, like on a roller coaster, sometimes you would be forced into the seat and you'd feel really heavy, and so your apparent weight would be greater than it really is. And sometimes you would be lifted up out of your seat, and again your apparent weight would be less than what you feel. And so that's a measure of the weight force and the reaction force that you're experiencing. Again, that's why we're talking about it in Newton's laws. So it relates pretty much to Newton's third law. So for an example, if we have a man weighs 65 kilograms, what is his weight on Earth, the Moon and Jupiter? On the Moon the acceleration is 1.6, on Jupiter it's 24.9, so you feel quite heavy there, and you can see the weight force varies. The mass remains the same, but the weight force, so on Earth you'd feel a force when you're sitting down or standing up or whatever of 650 newtons, but on Jupiter you would feel a good 3 times almost heavier, and so everything would be quite a lot of effort to do, whereas on the Moon you're a lot lighter. So that's enough about weight, and in the next video we'll talk about terminal velocity. See ya.